Okay, so your problem is giving you a derivative function, x to the fifth plus 4 root x, and it tells you that f of 1 is equal to -9, and it wants you to find the particular solution, essentially to this differential equation. So since they give us the derivative and they tell us something about the original function, we're going to want to go backwards and find the antiderivative. That's what it says in the question. So we're gonna find the antiderivative of this function. So I'm just going to draw the little integral symbol in there, put a dx at the end because we want to find the antiderivative. So the antiderivative of this isn't too bad. It's just the power rule for antiderivatives, and since I don't know exactly what you need or what you know, I'll just write down the power rule for antiderivatives over here. If you're going to take the antiderivative of x to the n power, then you're going to add 1 to the power. So n plus 1. And divide by the new exponent. So we should be able to utilize that here for both of these terms over here. And notice I took the square root of x and I rewrote it as x to the 1/2 power, so we could do the power rule with it as well. And you should be familiar with that from taking derivatives. When we take the antiderivative of x to the fifth, we'll add 1 to the power, make that x to the sixth, divided by 6. And then the next term, we will add 1 to the power, x to the, so 1/2 plus 1 should be 3/2. And we will divide by the power of 3/2. Okay. I don't know about you, but I don't really like dividing by this fraction. So instead of dividing by 3/2, we'll say we're going to multiply by the reciprocal. So I'm going to multiply by 2/3. And still have x to the 3/2. All right, pardon my writing here. I'm writing with my finger on a keyboard. But this should be our general antiderivative. And if you remember from class, when you take an antiderivative, it could have a plus c at the end, or it has some constant term that could be added to the end. And that's really what we're trying to find after we find the antiderivative, is we're trying to find that particular c value that works for this function value that they gave us. So this would be our antiderivative function f of x. And we just want to make sure that when we plug in 1, we get -9. So the last part of this problem is we're going to plug in 1 for x and set it equal to -9. So if I plug in 1 for x, I'll get 1/6 there. Plug in 1 for x, 1 to the 3/2 is still 1, so that's not going to do anything. So I really just have 4 times 2/3. 4 times 2/3 is 8/3 plus c. And now if we do a little bit of handiwork and figure out what c is, we'll have to get some common denominators and solve this. This is a 3 down here, so this is 16/6 plus 1 is 17/6. So that's -9 equals 17/6. And if we subtract that to the other side, -9 would be -54/6 minus 17 would be -71/6. -71/6 equals c. So your answer should be your function x to the 6/6 plus 8/3 x to the 3/2 minus 71/6. And that should do it.